Okay, so in order to do this question, the red colored for a reason because it requires thinking. You cannot see it directly. Okay, so I'm gonna go through my series of thoughts with you. Okay, first of all, I know that this cannot be perpendicular bisector of chord because this is a chord, this perpendicular bisector, but this is definitely not in the center. Like use common sense, 用眼睛看. Just see, it's not in the center. Okay, sure, it's not in the center. It's definitely not perpendicular bisector of chord. Bisector of chord. It's definitely not that. Okay. Next, we also know that it's definitely not it's not angle at center equals to 2 times angle at circumference. Definitely not. Why? Because there's no center. If there's an angle at center, then there will be something at center. There's nothing. There's no O. There's no like middle. You never put a dot here, then label this O. And even if so, nothing is intersecting it. It's O is just there. Nothing's intersecting. You cannot assume AE intersects O, by the way. You cannot assume. So there's nothing intersecting. I mean, it's true. AE intersects O. Reason being, AE is a diameter. It definitely intersects O. But there's no O in this case. Okay? So even if you draw one here, it's pointless lah, because it's basically there's no like a next angle something like that. It's different. Okay, so so now I know definitely there's nothing there. But however, I take a look. I remember my second property, which is what? Angle at same segment. Doesn't matter which segment. Okay, so let's take a look. Can this work? Because why did I think of this now? Because there's an intersection. There's no intersection other than this intersection. So you see from this intersection, you know there's something wrong. Means there's something up to you already, right? There's something going on. You see there's an intersection. Oh, you know intersection, and this intersection is not in the center. Not in the center. It's at the side. It's anywhere but in the center. So if anywhere but in the center, it's most likely angle in the same segment. Then there's an intersection. Okay, so I try to figure out a way to prove my point of angle in the same segment. How is it angle in the same segment? I don't know, but I'm trying to prove my point. Check, is it true that this hypothesis of it being using this property is real? Is it real that I'm gonna use this property? I don't know, so I'll check now. Okay, so this is the not sector, it's a segment. Sector is from the middle. Yeah, so there's this line, and then I draw another line from C to E. From E to C. Then, if you can see, this is actually a cyclic quadrilateral, if I'm not wrong. So you can clearly see, it is what? It is angle in the same segment. How do we know? This is your minor segment. Over here, this is your minor segment. It's very small. It's like that. This whole thing here is your major segment. Okay, if you can see. So you see this line over this blue line, cut across is your minor segment. Okay, so what happens is that we know this is a minor segment. So we know that this point is on circle, this point is on a circle, right? So this angle, specifically this angle here, BAE, which is what we are trying to find, BAE, okay, BAE here is also equals to this angle. Why? Because angle in the same segment. Yeah. Now, how do we go about to find this angle? We know that AE is a diameter. So when something is on the diameter, what is this? Right angle lah. So what is this? What is this property name? Right angle in a semicircle. This is a semicircle, am I right? Because this AE is a diameter. So actually this angle here is a right angle. And this is a compound one. No matter if it's like that, or it is like that, then it's like that. Confirm this one is right angle. Okay, so I know that this is right angle. And angle sum of triangle, I know that this angle is what? 180 minus 18 minus 90. So it's actually just 90 minus 18. So it should be 72. Yeah, 72. So this angle is 72 degrees. So I will label it down. Remember to write your reasoning. Angles, the sum of triangle. 72 degrees. Okay, so I know 72 degrees for that, but do I know this angle? I know right, it's 90 degrees, right? 90 degrees. So I know that angle. This angle. I can find angle E C D will be equals to 90 minus 72 degrees. There's no reasoning for this. 18 degrees. Yeah, can we understand that? Yeah, I understand that. So we know that ECD is 18 degrees. We also know that BAE will be eventually be 18 degrees. This is 18 degrees. Reasoning, angle BAE is equals to angle DCE, which is also equals to 18 degrees. Reasoning, angle in the same segment. And that's all. Okay, so angle ACE is equals to 90 degrees. Why? Because this is a right angle in semicircle. So that's all you need to find. Yeah, this for and my bad. Maybe it's a bit not tidy. Okay, let me tidy it up. Angle what? ACD will be equals to 180 minus 90 minus 18 degrees will be equals to 72 degrees. Why? Angle sum of triangle. And then your answer will be 18. So you went the calculation, you also know, I don't even need to do any calculation, you also know in the end answer is 18. But do you write 18 now? No, you have to show all of this working. All of this working. But if there's a shorter way, it works. So BAE